should approximately be rolling. Okay, by the way, is Python your language? Your preferred language?
Yeah.
Okay, perfect, perfect, perfect. All right. Okay. So what I'm gonna do is, first of all, I almost forgot to say, yeah, welcome to the mock interview. I'm very thankful that you're able to join us today. By the way, we're gonna I'll remind you of the format. I'm not sure if you're familiar with the format. So it's 1 hour format. It's 1 hour interview. We'll go right to the problem, right? We're gonna spend about
Hmm.
45 minutes on the problem today, okay? We might do one, we might do two, depending on the time, right? And at the end, we'll give you like 10, 15 minutes for feedback, all right?
Sounds good.
Okay, so for this problem, now I'm gonna start off by reading the problem out to you. This is going to be
Hmm.
a pretty common format for some companies. If that's not what you want to do today, if you just want to see the problem as is, let me know. All right, but I
Oh,
want
no,
to
no, I
help you.
prefer you read it out, yeah.
Okay, okay, perfect. Okay, so this is a leak code problem, right? So what the problem is going to be is it's called search insert position. All right, so here's a description. I want you to write me a function, which is
Hmm.
going to take a sorted array of integers as input, and it's also going to take in a target value. All right,
Hmm.
and then if the target value is found in the array, I want you to return the
Hmm.
index. All right.
Yes.
And if it's not found, I want you to return me the index it would be if you were to insert it.
If not, okay, I see. Concerning where it would be in index. Sounds good. Okay. 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 Is that all?
Yep, that's the entire prompt. Feel free to ask me any clarification questions.
Yeah, sounds good. Okay. So we have, I guess maybe if I can repeat the question to you. So given a sorted array as well as a target value, what we want to do is check to see if the target value exists within the sorted array. And if it does, we return the index position. If not, we then would return where it would be if we insert it within the sorted array. Is that correct?
That's right. That's right. Yes.
Okay, okay, sounds good. Okay, let me just have some sort of templating here. Okay, perfect. Okay. Let me see. And this is a sorted array of integers, no floats, nothing
That's right.
of
Sort
the
of.
sort.
Yeah. Integers only.
Okay,
Yeah.
okay, okay. Okay. I don't think if it's either positive or negative values, I don't think that really matters. Okay, I see. Okay. I guess, is there a preferred like time and space complexity that you want me to go for? Or?
Yeah. I would prefer you to optimize for time.
Okay, sounds good. Okay, okay, okay. Perfect. Okay, and then I guess if I can, let me go through an example real quick and then just kind of to outline how I want to approach this problem and my sort of solution.
Yeah, for sure. Yeah. Feel free.
Okay, essentially, what we want to do is say we have an array of sort of values. Let's say do this with negative numbers, negative would be 1, 0, 1, 2, and we have a target value of say, this case, let's say 1. So in like this case, we'll succeed in that we will actually return an index, and then let me just have a separate example for later where we don't where the value actually doesn't exist within the array, and then so we cover our two main cases, right? Essentially, okay. For the cases where we have where the target value exists within the array, we would essentially just iterate through, maybe starting from left index onward, and essentially go through one full pass. If we end up finding the target array, we would then insert it. Sorry, we would then return the index position. However, in the case that we don't find it, essentially the how we know for sure that we won't find it is because since it's sorted, essentially, if we come across a value that's greater than that's greater than our target value, we know that we have gone like anything beyond that point, we won't find that target value. So we can just assume wherever the case where the index like how to explain this. Say you had like 4 here, like whenever we come across a value where that's greater than the target, we just I believe I want to say we say this index position becomes the where the target would be, and then we would just return that. Does that make sense? What I'm saying, or kind of
I
like
think you're on the right
tangled?
track. I'm not sure if exactly what you said was correct, but I think you're on the right track. And I might have misunderstood what you meant there, but
Okay, maybe I can rephrase it real quick. Essentially, what I'm saying is for the case where we know like the target value won't exist within the array, since it's a sorted array, right?
Yeah.
As soon as we reach a value that is greater than our target, we know anything onwards, we won't find the target. We won't find the target because it's sorted, right? So
Yeah.
it then means that the target value must be then inserted here, where like the case where it's greater than, if that makes sense.
By here, do you mean always one
As
to
in,
its left, or do you mean to the left of that value
it
that
would be
is?
it would be on the value, I want to say,
It would be on the value.
because yeah, it'd be on the value because to the left, we would then hold on. Let me just think about this. Say n equals so okay. Say n equals like. Just walk through a quick example. Let's say this is like 3 and this is 2. So here, go through here, it's perfect. Then we come across the condition where this is less than this and 2 doesn't exist here. And so we would insert in this position, which would be on the value, right? And then this we can shift it over 1 to the right. So it'd be, yeah, it would be on the value.
Okay. Yeah, I think you're correct on that.
Okay. I guess, and then I'll just implement that. In this case, this would be O of n, because we're going through one full pass, space, and then O of n time, and then constant space, because we're not really adding on, like, we're just returning the index position, right? So we're not really doing anything else besides that. Okay, yeah, so we can just take in, I guess, an array, target, say, target, and then we would do for I in range. Since we're working with indexes, we want to actually iterate over the index positions of the array rather than the array elements themselves. And so, but also, am I speaking too quick? One of the main things is that I kind of talk really fast, which is why I'm talking.
No, I think you're fine. I think you're fine.
Okay, perfect. So if array is, I guess in this case, position is equal to target, we'll just return the I. This is a little funky. I don't know. Okay, this is off. It's kind of, okay, I'm gonna just, yeah, okay. Oh, I see why. Okay, there we go. LF target of I, sorry, oh my bad. If it's greater than, actually, yeah, okay. Return I. I think this should work, right? Because if this doesn't trigger, then this will just trigger. I'll need an else here, but it's just for make it look cohesive. And then yeah, this should work. I guess maybe I should run it in a few test cases. Print, I guess func. What do we do? Let's just run this case up. Let's just run both these cases. Boom, and then do 1 here. Why is this erroring out? Okay. And then run this case. Bam. Bam. Okay. This would be 0, 1, 2. Yep. 0, 1, 2, 3. It should be 3. Yeah, that was good. Okay, I think this is all of it. Yeah, so and then this would be like O of n time, and then O of 1 space, or constant space.
Okay, cool. Can we do better time?
Can we do better time? Yes, we can actually. This can be constant time. We can do that instead is, actually wait, hold on. I got too excited. Wait, can we do better time? No, because you have to find, you have to iterate through the array to figure out where its target exists, right? And then also it's also returned the index position, so you can't do better than O of n, unless maybe. Oh, I guess no, you can do better if you do because if you do like a binary search, where you essentially I'm just gonna just comment this out. do binary search and split on the half. I haven't done this since my exam. Okay. If you have like a I think it's low, high, mid values. Oops. Where low would be equal to, or the left, right, doesn't, I guess low would is equal to the 0, high would be equal to the length of the array. I guess essentially what I'm trying to say is here, since it's sorted, we're able to do binary search. And essentially, I guess maybe if I can take this example here, just look it out and say target is, yeah, it's target 4. What we do here in this case is we look at the middle of the array. If the value is either, if the target value is greater than, and this value is less than, sorry, if the target value is greater than the middle point, then we know for sure that the target value won't be to the left of this array, it must be to the right. So then we shift our focus into the right, and then search through here. And likewise, if it's less than, then we know it won't be to the right of the array, and we shift our focus to the left. And so this reduces our time complexity from O of n to log n as the search space like halves over time. Yeah, this is mainly doable because the fact that it's sorted. And so I guess, yeah. Would you want me to implement the
Yeah, go ahead and implement that.
like this? Okay. If low is less than while low, I want to say dude, I haven't done this in a minute. Ooh, okay. Mid is equal to low plus 5, 2. So we just do floor division. If mid, and then so mid are going to be like our next value essentially. Oops. If the mid value, I guess, okay, this is interesting because this will help us. Like we will find either, like this case will help us find if the target exists. However, now I'm thinking, what do you do about like where it would belong? Like how do you keep track of that? Like say you don't find it, how do you figure out where it should be placed instead? This would be -1, I think. Okay, let me just go through an example in my head real quick. If in this case, since it's less than 2, sorry, it says, yeah, this is less than 2, you look to the right. So low then becomes this plus 1, high doesn't change. You look here, and then you do low plus high, floor division, divided by 2 on down, and then you check to see, boom. Oh, I guess, interesting. It'll technically, I see. I think once the midpoint converges to a final value, that's where target would actually be, right? Yeah. Okay. I see. So that's how that works. Okay. But what I said make sense there? Like, am I like rambling or?
I don't know what the midpoint value is if the target does not exist in the array.
Okay, so essentially, it's like binary search, kind of like when it's looking for a value, it kind of converges onto a final point, correct? If that final point either becomes target, or if it's not, it's going to be where target is supposed to be, if that makes sense.
How does binary search end if the item is not in the array?
It'll always just it's either less than or greater than. So if it's less than, then you look to the left side. If it's greater than, look to the right side. But then at some point, you're gonna have an array of length 1, and like your search space will be of length 1, and that'll either be the target or that'll be where the target is gonna be within the array. If that makes sense.
Okay, you can go ahead and implement that.
Okay. If array mid is equal to why am I blanking right now? Sorry, it's like 8 p.m. at East Coast. I'm dying. Okay, yeah, if array is equal to target, let's return. Return mid. mid, and then elif tar. So if it's okay, elif. Uh, okay, this is gonna look a little fugly. I'll just do it this way. Whatever. Okay, if this value is actually, you know what, elif length. Let's say like, and then so this case will cover if it's found. If and then this second elif statement is going to cover if it's not found and we have an array of length of one. That means there's no more space. There's no more part of the array we can search. Therefore, like it's gonna, the target is going to be here instead. Like the target won't be found, and instead it'll be sort of within this position of the array. So in that case, you come to that case if won't be the length necessarily. It would be if L plus H. Let me think of it this. I want to say it's a difference. It's the difference between these two values is equal to 1. Then like, oh sorry, return mid, because then mid is like our index position. And then yeah, so these will hit if like these cases will hit if we either come across it or there's no more search space left. And then if besides that, I'm gonna have a second set of if statements that kind of like dictate where the binary search goes, right? So either you go to the left or right side. So if over mid now is greater than the target, that means what does that mean? What does that mean? Yeah, so if this is two, okay. We have to look to if the mid value is greater than the target, then we have to look to the left. Okay. So that means high gets dropped down to mid, -1, and low stays the same, and yeah, essentially you just change your high value. And then else, I guess, yeah, else, because, yeah, okay. Else low gets changed to the mid value +1, and then boom. Yeah, and then this else case will trigger whenever if this else case triggers whenever it's whenever you have to search the right side of the search space of the array space. Yeah. This is I'm iffy about. I don't know if this is true. Like if that's a condition. Honestly, I'm gonna be lazy to do this. I don't know if this is cheating, but okay. Just okay. Okay, I think this is my solution. Well, I can let me test it. Please work. Nope. Okay. Index out of range. Okay, that's what's gonna happen. Okay. 0 length of
Yeah,
-1.
so one thing that's interesting is that you're
Hmm.
always
That's not.
assuming L is less than H, correct? Less than equal
L
to
is less
H.
than 8. Oh yes, so it should be, yeah.
Um, is that true though? Like I'm trying to look at your code. I'm trying to. Oh, by the way, I'll just tell you this.
Yeah.
You need parentheses here. Try it
Oh, I
again after
do.
that.
Okay. Okay. Okay.
That might be your issue.
Uh,
Try running that first. See what happens.
okay. Should I get more test cases?
No, that's fine. I'm not concerned about that. Can you tell
Okay.
me? Can you tell me the time and space complexity, please?
Space time gets dropped down to log of n, and
Okay.
then space stays the same as constant because we only have 3 variables here.
Okay.
Low, high, mid.
What about using the slice syntax on arrays?
What about using the slice syntax on arrays? Oh, that's a good question. Is that O of n or is that O? Or is it constant? I'm not being lazy here. I think slicing. Fuck. Oh, if it's slicing, yeah, it's oven. Fuck. Okay. I want to say slicing is O of n takes O of n time. Wait, is that true? Just like out of curiosity.
Yes.
Oh, it is okay.
It also
All right.
requires O of n
So,
space.
wait, actually, is it because you make
Yes, that's right.
make a new array out of? Okay. Right. Okay. I'm gonna just honestly hold on. Just bear with me for a second. It's either 0 or 1, I think.
Okay, okay, that's fine.
Okay, okay, it's 0, okay, it's 1. Okay, that works too. Okay.
Okay, cool. I'm gonna leave this problem for now. I want to move on to a second problem. All right.
Sounds good.
So for the next problem,
Oh,
this is also an array problem. All right. So in this problem, you're given a list of sorry, or array of nums, list of nums. You can call it whatever you want. A list of integer,
okay.
and
Yep.
one of them appears the majority of the time. That is more than half
Okay.
the time.
Okay.
Okay. And I want you to return the majority element.
Majority of okay. So return the most common element within an array of integers.
Yes, that's right.
Okay, sounds good. Okay. I guess. Okay. Is there a preferred space and time complexity?
I would like you to optimize for time for now.
Time. Okay. Wait, can we use like libraries?
You can use whatever you want.
Like
Yeah.
okay. Okay. Huh. Okay, interesting. Hmm. Okay. 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 I'm gonna use essentially what I'm gonna do is I think there's a better solution than this, but I guess I'll just write this out and then go from there. Essentially, what I'm gonna do is import. I'm gonna create a dictionary, like a hash map of a frequency map of all the numbers within the array, and then from there on, iterate through that frequency map to identify which integer occurs the most. So it would be O of n. This would be O of n space, and then O of I think n time. I guess maybe I can go through an example real quick. Well, I mean, what that would look like. So given 2, 3, 4, 4, 5. I guess. Oh, quick question. Can there be ties?
No.
No. Okay. So there's a unique solution to every. Okay. 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 So. Okay. So in this case, this would be clearly 4. Um, and what, yeah, this would be 4, and then essentially what we would do is I'd use the counter function within Python, and essentially just create a frequency map where the key would be the actual the actual value in the array, and the value of the key would be how often it occurs, and then from this frequency map, I'm then gonna iterate through all the keys, all the key value pairs, and I'm gonna have a max variable instantiated, and pretty much just look for the maximum, like the maximum amount of times, like the maximum frequent value in the array based on just the value pair of the key value pair, if that makes sense, and then return the key. Does that make sense? I kind of sped through that last part.
I get what you're saying. Yeah, let's see it.
Okay. So, given array, uh, okay. I think it's from collections import. By the way, would you allow, like in an actual interview, would you allow use of like libraries or not? Like I mean, built-in functions or no?
It depends on the
Is it
interview.
usually allowed?
For
Okay,
this
okay.
one, counter doesn't actually help you, but we'll get there.
Really? Oh shit. Okay. Wait, 1 appears majority of the time. It wouldn't help me? Okay.
You can solve it with counter, but it's not optimal. We'll get there.
Oh, I see. Okay. Yeah, I figured that is the case. I guess you do hash. I guess freak map. Would then just be counter. the array, and then you would do for is it hmm I want to say there's a way, I'm blanking right now. There's a way to iterate through key value, like to detuple it,
Yeah.
decouple it, where you get the key value per. Do you know the syntax, just by chance?
Yeah, it's just frequency map dot items.
Oh, okay, yeah, okay, thank you. Oh, I see. Yeah, and there's okay, perfect. Okay. And then, yeah, then you probably, yeah, you know what I'm gonna do here from now on. And then yeah, max value. So max um is val, and then I guess, what would you call this? I don't know. Like most frequent. No. And this would then be like just do -1. This would then just be float. Just have like a placeholder value of so, and then bada bing, bada boom, and then yeah. Um. Uh. Okay. You would do if max of these two values, so of this and the value doesn't equal max val, then you would update this value to key, and then you would then update. I'll explain what this does in one moment. And then you can just return this. Okay, essentially what this does here is we're checking to see, so we instantiate two placeholder values, and we're checking to see, sorry, we're checking to see if the current like um value within the array is the most frequent. If it is, which is what this says, then we update our most frequent value to that value because it's most frequent, and then we also update how much it's like its frequency by, right? And then that's pretty much just a typo. And then yeah, that's how that all works. Does that make sense?
That makes sense. Can you tell me
Okay.
the time and space complexity?
This would be O of n space and then O of n time.
Okay. All right. I'm gonna work with you on a follow up here. Okay.
Okay,
So
sounds good.
it is possible to solve this problem with linear time and no extra space. Okay.
Linear time.
And
No, actually, okay.
and I will help you walk through the algorithm. Okay. So this is called majority element, right? And just to be
Mhm.
clear about majority means it appears at least half the time, right? Doesn't mean it means, I mean, saying that it appears in most times is correct, but that's weaker, right? It appears at least half the time, which is a much stronger
Okay.
requirement, right? So
Mhm.
here is the algorithm that I want us to work on, okay? So given that this is what we'll do is, by the way, it's not sorted, right? So we don't know if it's sorted or not, and whether or not sorted doesn't
Yeah.
matter, okay? So we're gonna track two items as we iterate through the array, okay? We're gonna track a candidate value, and then we're gonna track how often this candidate value has appeared. By the way, you're free to take notes if
Mhm.
you want. I'm also happy to
Okay.
repeat this afterwards, okay? So we have a count and we have a candidate value. Okay, so
Yeah.
at the start, our count will be 0, and
Mhm.
our candidate value will be equal to the first item of the list. And here's
Okay,
what we're
sounds good.
saying, is we're going to say, we think that the first element in this list is the majority element. And that may or may
Mhm.
not be true. It doesn't matter, right? But that's our starting state. And what we're going to do is as we iterate through the list, we will process every item as it comes, right? So here's how it's going to work. When we encounter an item, or a value, sorry, when we encounter a value, if it equals our current candidate value, we increase the count, right? Because this
Yeah.
reinforces our idea that this is the correct value, right? If it's not equal to the current value, to the current candidate, we decrease the count, okay? And the key thing here is that once our count reaches 0, we restart. In other words, we restart as in like the count goes to 0. We set our candidate value to the next to the next value, right? So for example,
Oh, okay.
okay. So what does that make sense? Okay, and then just to kind of
Yeah,
just
yeah,
gonna
yeah.
finish the algorithm off. Okay, so whatever item is our candidate item after iterating through the entire array is our answer.
Sounds good. Okay. Yeah, okay, I see. There was I had this in my head, but the base case that I was worried about is, say you come across, for instance, like over here, I actually kind of fixed it up. Say you do that value, you do the algorithm, and however you didn't do the part where you decrement if you don't come across it. My issue is if you say, for example, so you start off at 1, and your candidate value is 1, your frequency is 1, but then you start off at 2. Then you go over, you see 2. So what you do is you reset the candidate value to 2, but then the frequency would also, the candidate value would be 2, the frequency would be 1. However, if you came across 1 again, how do you know to go back to, look, your two variables don't have, like, they don't know that 1 existed before then, right? So that was my issue, and that's why, okay, I see. But then if you decrement, okay.
Yeah.
Oh,
So
okay,
another way to
okay.
think about this is essentially we assume that we don't need to assume. We know that the majority element can
It's at least half.
cancel out every
Is
other
it?
element and still have at least one left.
It can cancel
So,
out.
right? So you could, if you when you're at this point, let's say for example, we have a list like this, right? We don't know what's going on over here, right? We have
Yeah.
1 and 2, right?
Mhm.
The thing about 1 and 2 is that first of all, if neither of them end up being the majority element, these two don't matter anyways, right? The answer is the same. If we had the rest
If
of the
neither of
array
them,
versus if
okay.
these existed, if neither of them were the majority element, right?
If
Like let's say we had, for
yeah, okay,
example,
yes, I see that, yeah.
we had a bunch of threes here, right?
Yeah.
Right. In this case, it doesn't matter if there's 1, 2, or these two didn't exist at the start. Like they're irrelevant,
Hmm.
right? And if 1 or 2 was a majority element, they would just cancel each other out, right? Let's say 1 is a majority element.
Hmm.
So what we say is the majority. So let's say we have let x equals this, right? So majority of x equals 1, but majority of x from 2 onward is still equal 1. Do you see what I mean? Like if you get rid of the first 2 elements, it doesn't matter. The answer is the same. And the reason is simply because the majority element will always have enough elements to cancel everybody else out. That's the
Because that's
definition
at
of
least
majority.
half, right? Yeah.
Yes, it's going to be at least half,
Okay,
right?
I see.
So at this point, we don't actually know if the majority is 1 or 2, right? But we don't
Hmm.
care because if it was 1 or if it was 2, it doesn't matter if we get rid of both of them. That's essentially what resetting or decrementing the count does.
Okay, I see. And then that solves the problem of, like, you don't have to, you don't care about what happened before then, right? Yeah, okay.
Yes, like in other words, if you pretended the array started here, right? I know this is not
Yeah.
correct syntax, but if you imagine the array started here again, right?
Yeah,
You
yeah,
don't
yeah.
actually care what happened before this. Like this is
No, you
irrelevant,
don't. Yeah.
right? So basically,
Okay.
this is what. And but over here, your count is back to 0. This is what we're saying is we're starting anew. We're starting fresh again
I see.
because the previous history doesn't matter. So essentially, whenever your account equal to 0, you essentially just set the next candidate to be whatever the next value is.
You set the next candidate, yeah, and then you would decrement. Yeah, sorry, what's a 0, then you start anew, and then,
Yeah,
yeah,
when it's
okay.
0, you just start anew. You say, all right, I assume Y is a candidate. Let's move forward.
Yeah, because at that point it's 0, right? So there's no, yeah, okay.
Yeah, at that
You
point
don't
it's
care
0.
what happened before.
Well, at this point
Okay.
it's 0, but when you set Y to be the candidate, Y count will equal 1, right? Because we have one Y. But yes,
Okay.
when your count reaches 0, that's when you know you need to restart the algorithm with the next element.
Okay, so, yeah, okay, I see. That makes sense. Wait, would you want me to code it up now? I mean, there's
Yes.
not much to it, I don't think. It's just, you still have the for loop. Uh, for I am, I guess it doesn't matter. I'm not press array class, and then you'd have candidate value. Actually, no, this doesn't matter. Uh, sorry, this is not complete. There we go. And then would be array, the first value, and then your, I guess, freak is equal to 1, and then now we just check to see whether if the if it is the value. So if the candidate value is found again, oh sorry, if so do array I is equal to the candidate value, then you increment the counter, which essentially like is a frequency, by 1. If it doesn't, I'm sorry, if they're not equal, then you decrement by 1, and then I guess as well, it's a little ugly, but I guess a second like if trigger. If then you're after decrementing, the counter becomes 0, then you say the candidate value then becomes the excuse me, sorry, and then you just return to bring in. Oops. Okay, I see. And yeah, I think this works.
Okay.
Yeah. Okay.
And now can you tell me the time and space?
The space, times unchanged space becomes constant because we only have two variables.
Okay. Yeah, that sounds good.
Okay.
All right, what I'll do for the last problem, I don't know what time to do this, but I want to get started on this problem. All right.
Okay.
So
Sounds good.
this is a problem where I'm actually gonna just I'm gonna paste in an example and then
Okay.
talk over it.
Sounds good.
Okay, so this is a problem where you're going to be given an input array of numbers of integers.
Uh-huh.
All right, and you are to output what we might call the consolidated ranges of these numbers. Okay.
The consolidated range. Okay.
That's right. So you have a list of consolidated ranges. So what does that mean? Well, that means in the input array, some of the integers are contiguous, right? Or they're one after the other, right? For
Yeah.
all of
Yeah.
those, that's like one contiguous range of integers. And so you need to represent that with the starting point, arrow, ending point.
I see. I see. Okay. Okay. Yeah. Yeah.
All right. And if
I
integer is
see.
just by itself, then you just put the integer itself there.
Okay.
And the given is that the integer the integer list you're given is sorted.
It's sorted. Okay. Perfect. Okay.
It's sorted, and
Sounds
there may be
good.
duplicates.
There may be duplicates. Okay. Would you include the duplicates? Actually, yeah. Like, well, okay. So, for example, within duplicates, would it count as like the end of the contiguous array or the start of a new array? Like, if that makes sense.
They're all part of
For
the same
instance,
range.
okay. Yeah. Yeah. So, okay. For in this case, say at 1, 2, 2, 2, it would fall under this.
That's right.
Okay. 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 I see. Okay. Hopefully, how much time do I have left? Okay. I'll try to speed run this in like
We'll have 7 minutes.
1 minute.
We'll see. We'll see if we can get through it.
Brief. I mean, okay. I think you could do this in O of n space, sorry, time, by just iterating through, and then since it's sorted, you have the gift being sorted, so you iterate through it, and then you could keep track. Oh, so yeah, actually, sorry, you could iterate through. You could just iterate through, and then as soon as you could do a little peek over to the next value, if it's not like contiguous, then you append to some final array, like your what's it called again? Sorry, the term.
Contiguous or range?
Yeah, yeah, the range. Yeah, you input like this syntax onto the array, and then just continue on with the next value because you peeking over lets you see like if the value if it's contiguous or not. That makes sense. Does that make sense?
Yes.
Okay. I guess okay, and I don't think, and then wait. Would you want me to just focus on time complexity?
This one should be about the same either way.
See, okay, all right, yeah, and then it has to be O of n.
Yeah.
Like O of n space, because worst case is like they're all uncontiguous, so you just have like one element after the other.
Yeah, that's right.
And then O of n time. Okay, sounds good. So yes, we should iterate through for I in range length of this bad boy. Okay. Oh shit. Okay. Okay. I guess you do again, and you also have to keep track of the start point. So you could say like start um, would equal, I guess, like nums of zero in this case. Ooh, I don't know why I said there. Nums of zero, and then you also have an end value that then keeps track of like the endpoint um, of the contiguous array. Um, let's just have like a temporary value of like float negative. Okay, let me host some. Okay. This has to get updated. Sorry, oops. This has to get updated based on the thing. Let me just, uh, actually, no. This also can just be. This can also just be the same thing. Like these can also equal. Uh, as of right now, because you like this is a case, so this is valid technically speaking. And then you just do start off here, and then you'd have a base case here saying like if the array is one, just so that this doesn't crash, you just return like the thing. I guess is it okay if I ignore that, like the base case of length nums
That's
of
fine.
one?
Yeah.
Okay, okay, okay. Okay. If if I guess end plus one is equal to array at I, then you append then n becomes the value, right? So and then else it's not like else this is not true, and then you append the start value. Oh, this okay. This is interesting. Let me just do this. Start. Is this valid? I think you can do it like this, right? You can do it as string literal.
Yeah, you can.
Okay, okay. And then do this, and then yeah, you just append this, and then you'd update. Start with then equal to, well, equal the same, so then equal to their start value, and then to return. I think this is, yeah, I think this is it. Did this cover like the last case? Yeah, I think so. Yeah, I think this is good.
Okay.
Yeah.
Can you walk me through how your example can output 7?
Oh, that's a good question. I don't think it can. Wait, can it? Um, can my example output 7? Let's see this. Zero. You start off with zero. These are both zero. You check one. Is zero plus one equals to one? Yeah. Boom. So yeah, okay. You got the comes one, and then two, boom, four, no. So you add zero, okay, and then they become yeah, okay, and then five. Now you check. Now you start off with four. Is four plus one five? Yes, it is. So then n becomes five. You don't update start, and then seven isn't the case. Ah, you don't cover seven there. Okay. Uh, okay, I see. Okay, I see. Yeah. And then you just do like you just do if if I is equal if I plus one is equal to array. This is like edge case. Then I want to say then you would just do this. Doesn't matter either or. Ooh, this then yeah yeah okay. I think this should work.
Okay.
This covers the edge case. Yeah. No.
Can you run the code with the example we have?
Yeah. Uh, oops. Okay. Please work. No, dude. Maybe is this. Hold on. No, okay. There's a reason why this doesn't work. Why is this not working? Let's see. Uh, okay. Okay, you have five. Five plus, your end value is gonna be five here, and then you're at seven. Five plus one doesn't equal seven, so this doesn't get run. I see. This is too, yeah, this is too strict. Like if this isn't true, then this holds, which isn't true. Uh, hmm. This might work if you hold this first and you have this check happen. No. Okay, this, okay. Yeah, hold on. Okay. Let me see if we can. Okay, does this run except for the last one? Okay, last one here. No, this fails here. Why is it not, why is it doing this? This doesn't make sense.
One thing you have to keep in
Okay.
mind is that your else will always run.
This trigger, yeah, I gotta, this is, okay. Um, hmm. Okay. If end plus one doesn't equal. If this isn't the case, then you end it off and you continue, right?
Okay.
What the Why? Well, hold on. Is this fault? Okay.
Yeah, like think of like this is a very interesting statement. You're saying if you're because I is an index.
Oh my God! I'm so sorry. I thought this was one. I'm actually hallucinating. I thought that was one. My bad. Okay, but okay, this holds, but we're getting dupes here.
Okay,
Why?
you seem to only have single value ranges now.
Oh, okay. Start end. Okay. Because end always updates, right? Start only updates whenever it's not contiguous anymore, and it becomes the this array. This looks like it makes sense, right? And becomes and end becomes this value, and then
Yeah, like this part is correct. One thing they got to keep in mind though is that like one thing I keep in mind is that you have like three statements and you're checking them all. No, you're checking all three statements no matter what. When in reality, that might not
uh,
be what you want.
okay, I see.
Right?
Sorry.
That
No, okay. I'm just
that's closer.
because these only trigger once, right? Um, why won't this work?
A better way to think about this is
Mhm.
actually to expand this statement conditionally. So
Conditional?
you shouldn't actually have a separate condition for just like this case because if you think about it, this is actually the same case as this, right? The only difference is that when you're going to write a number, you don't always want to write this format, right? If start and end equal the same thing, then you don't want to write the arrow.
Okay. I see. Then okay. So if it's not contiguous and you have two other conditions, and then those two other conditions dictate whether or not you print this format or this format.
Yeah.
So
There's also one more thing,
okay.
but I'm gonna cut you off here.
Time?
I'm gonna cut you
I
off
see.
here. You can go figure that out yourself at the end. It's not too hard. You're basically there.
Okay.
But I want to walk through the rest of the answer any questions, give you some feedback on the rest of the performance today. Okay. All
Sounds
right.
good.
So we did 3 questions today. They're all array based, not too difficult. How do you feel
Yeah.
about how you did today?
Honestly, I think I did pretty, like in terms of like execution code wise, I think I did pretty well on the first two. This third one, I don't know why the if statements trip me up. Like like conditionals kind of mess up in my head. I'm not too confident on, like I'm not proud of the performance. I think I got the time and space complexities right. Um, yeah, I think also overall, I think like sometimes there's been moments where like I kind of maybe talk too fast, or kind of sped through my explanation, so I could have slowed down through that. But yeah, I guess that's overall I guess my perspective of how I did.
Yeah, I think you're definitely right to focus on. I mean, the technical part is not the difficult part today for the three questions.
Yeah.
The main thing being tested here was basically communication, right?
Hmm.
And communication, only one part of communication is about what you say, right? So that's one part. We'll talk about that part, right? But another
Okay.
part is like you're saying one thing. Well, what are you doing, right? What is the interviewer looking at? What are they seeing you like communicate on the page, right?
Yeah.
There's other forms of communication as well in terms of like what are you like what is your clarity, like are you clear about what's going on, right? Are you communicating to the interviewer essentially that like yeah, I know what steps I know where I'm at, I know where I will need help, etc., right? So let's
Hmm.
talk about the talking part first. That's the easiest part to talk about, right? um, there were times where you're talking quite fast, but talking
Okay.
fast actually isn't an issue. It's only an issue when you talk fast about things that the interviewer does not expect, right? And then it's a problem because the interviewer is expecting you to say or do one thing and you're saying or doing another thing very quickly. Okay?
Yeah.
So
Okay.
there were a couple examples of that today where, for example, you were able to, for example, come up with the correct algorithm. That was very good. You're coding quite quickly, right? But at some point, you kind of get derailed.
Yeah.
You get a bit derailed, and it's unclear to the interviewer. Oh shoot, does this person realize where they are? Do they realize that this is a bug? Do they know what's going on here, right? So that's an
Hmm.
aspect. Is what you're doing a surprise to the interviewer? And if you're thinking about it from your perspective as a candidate, right, you should be making sure that you're always aligned. Like, hey, I'm about to do this thing. Here's how I'm going to approach it. Here's what's going to happen. And then you go do it, right? And that does two things,
Yeah.
by the way. The first thing it does is it sets expectations. And the second thing it does is that when you deviate from the expectations, the interviewer knows that you fucked up, right? Here's the
Hmm.
thing, the interviewer will know you fucked up regardless of what you say. Like, they know the problem,
Okay.
right? So the difference is that, oh, they know that you did not intend to do that. They can choose to step in and direct you, right? Now, they might not, right? But at least if they know, they have the opportunity to do so. So establish that expectation at the start, go from there. And by the way, it's going to depend on the problem, right? Some problems you'll be quite clear about how you want to implement these, right? For example, like what we did today, you were able to think of the algorithm pretty quickly, like you know what you want to do, right?
Yeah.
Other problems, you won't really know what the algorithm is. You might need to spend a bit more time exploring, drawing things out, sketching it out, etc. So for those cases, you might set the expectation that at the start, you're actually going to be spending time thinking about this or this approach or running through this or the other example, right? But it's just
Hmm.
important to set the expectation on what you want to do. And then that makes it like that is essentially a way to prevent fast talking from derailing the rest of the experience. So keep that in mind. It's not just about talking; it's about the entire like package.
Yeah.
Now, about the talking itself as well. This another comment I had is if you like, you should better understand why you're talking quickly, right? Like for example, oftentimes people talk quickly because they're nervous. And if that's a thing for you, figure out, hey, why am I nervous? How do I become less nervous? Is it practice? Is it the problem? Like, what is it about it, right? Like,
Hmm.
having mitigations in place is really helpful for short term performance, but actually addressing the root cause is much more effective in terms of like your time and effort in the long term. So figure that out. See what that might be. It might be practice on the technical portion. It might be practice on the soft skills portion. If it's about talking in general, you could also practice that skill via behavioral interviews, right? So practice the behavioral aspect. That's oftentimes a very good way to practice, like pacing and talking cadence.
Hmm.
And then if you find that it's because you're lacking technical backing, technical skill, then I think it's just a matter of continuing to grind Leetcode. So that's kind of your two main practice paths, in a sense.
Okay. Okay.
Okay, so that's
Thank
about
you.
the talking. Any questions about the kind of communication aspect so far?
I guess one overall, how was, because I think another issue is too, and you kind of briefly mentioned it, is like my cadence. And just sometimes I like speak over like very quickly, like some of the most important parts. Like I guess overall, how was that for me?
I would say there's kind of two things there as well. So the first thing is, I mean, the problems today, they weren't the most complicated. So
Mhm.
specifically the complicated parts, there weren't really any complicated parts, right? So that's going to depend. Maybe you'll get a better signal if you practice some more difficult questions. So you can come back to that. Now, in
Yeah.
general, there were definitely times where, for example, like these problems are pretty straightforward. I know all four solutions or whatnot, whatever they are, right? So I'd say, okay, which one are you going to pick, etc., right? But I think it's still helpful for you to slow down in the future, right? Like I understood what you meant, but
Yeah.
there definitely are going to be interviewers, maybe like newer ones or ones who maybe don't speak English as their first language, where that would have been too quickly. Now, that's not inherently a problem because interviewers who are good will actually ask you to repeat yourselves for things that are important. Um, but it does also help to develop the reputation during your interview that whenever you talk, it is something important. And that's something you can always work on, right? Like, don't say things that are going to be useless. Only say things that you either have confidence in or make it clear that you're currently thinking through approach or a problem.
Okay. Okay.
All right.
Okay. Yeah.
Okay. Anything else about communications?
No, I think that was like my main thing.
Okay. In that case, I'll just quickly say about the rest of the questions. Um, let's take a look. So, I think it's good to ask to focus on time or space. What I would also recommend is when you ask that
Hmm.
question, provide context on what the time and space can be, right? Uh, why is that? Well, you can ask that question no matter what, but sometimes it doesn't make sense, right? For example, in the last problem, there is no other time and space possible than linear space, linear time. So stuff like that is kind of pointless to ask, right? So if you're able to think about that ahead of time before asking, then it signals that you actually have thought about it. You understand time and space better versus this just being like an interview script. Um, Time and space in general today was pretty good, but also keep in mind that time and space for arrays can only be one of three options. So that wasn't really
Hmm.
tested, right? Time and space becomes more relevant once we get into more difficult problems with more data structures, right? Then you get a better signal there. But for what it's worth today, it was quite good. Didn't have any problems with that. Um, Another thing I'll say in general for this is the second problem with the pointers, binary search, right?
Yeah.
Now binary search is, I mean, yeah, people rarely implement it. It's not really a huge thing, but I think it is still really important to be very clear about for just in general for algorithms in general, by the way, is to be very
Hmm.
clear about what the starting conditions are and what the ending conditions are, right? So for example, a better description of binary search in your case would have been talking about the relationship between the left, middle, and right or low, medium, high pointers, right?
Yeah.
Like saying,
Oh,
and the thing is that that's not a waste of your time to talk about because those are going to be your if conditions. So think about that, be aware of that. Don't shy away from spending time talking about that kind of thing to make sure the interviewer understands what you're doing, right? This is more true, by the way, for like more difficult problems. Obviously, I know what binary search is. I don't know need you to actually explain it to me, right? But when I'm asking you questions about your approach or your language, that is just me
mhm.
double checking that like you actually know what's going on. That way, I as an interviewer know that if you fuck it up, is it because you don't actually know what binary search is, or you know what it is, you just can't code it, right? Those are two different skills.
Okay, I see. But is one like worse than the other? Like knowing what it is but can't coding it, or is it kind of the
Depends on
same
what the
extent to a
depends on
signal?
what the hiring manager wants, right? Do they
Okay.
want
Okay.
someone who knows more skills or can do more things?
Okay. I see.
All right, and then the last comment I had is about the last question, right? So this one, the main thing is just like you have the algorithm, you know the details, like you can sketch out the high level approach, but
Hmm.
there's just a coding issue, right? And the coding issue is two things. The first thing with the coding issue is that you didn't know there was a bug, right? Like you couldn't, like I'm not saying you couldn't, but you didn't see it. Like you didn't say that there is a bug, right? Um, I'll just tell you right now that for interviewers who know the question, I mean, I don't know I just pulled this random ass question out. Like interviewers who do conduct interviews for like these technical questions, for
Yeah.
obvious bugs, they for sure are able to tell, right?
Okay.
Sometimes for off by ones, they won't be able to tell, and most times interviewers won't like run it, like they don't care, right? But for obviously logical bugs, they will be able to tell. And so if
Hmm.
you are able to determine that you have a bug, even if you're out of time, you should say that yes, there's a bug here. Here's how you can reproduce it. Here's the situation. Better yet, here's how I would fix it. Right? Like that's something which I would definitely say. And then the second thing is, you knew the bug, you knew how to reproduce it, and it was still a bit of a
Mhm.
struggle to kind of get to a place where you can fix it. That's
Yeah.
more indicative of like just lack of experience with the actual code, right? So that's when you want to practice, just practice going through code, writing these kind of functions, because like one thing I think you're very good at doing is you can find the approach, but it's a different skill to code the approach, right? A different skill entirely. So two separate skills. Make sure you practice both evenly. Okay, that's kind
Okay.
of all the feedback I had. I'll send you the notes later. But anything else you want to ask?
I guess actually one last thing that's kind of separate about the like just overall like mock interview thing. Are you still gonna be running these after a while, or is it kind of like a different setup now?
I haven't really
Because I
figured
remember you
out.
mentioned the Discord. Okay,
Yeah,
so
yeah, I
go ahead.
haven't really figured out what I'm gonna do with this. I'm probably not gonna take too many more active mock interviews, but I likely will. I mean, I'm still active in the servers, and I think if there's demand for it, I'll do it on like an ad hoc basis. I just don't like the
Okay.
public sign up forms. I think the ghost rate is too high for me to tolerate.
Okay, that's fair. Okay, yeah, I think that's all for me.
Okay, well, that's all for me as well then. Thanks for coming out, and hope you had a good
Th-
experience. Take care.